All right, this is Honors Algebra 2 Pre-Calculus. We're doing section 1.2 in Algebra 2, which is writing the equations of lines. So in example 4 and P4, we're going to write the equations of lines that are parallel or perpendicular to given lines. Here's what makes this different from E3. In this situation, we're talking about being parallel or perpendicular to a line that is not written in slope-intercept form. So what that means is what you need from this original line, or old line, as we've been talking about it in the last example, is you need the slope, but the slope is not readily apparent because this is not in the familiar form you're used to. So let's go ahead and walk through A. All right, so the first thing I need to recognize is that there is an old line, right, which is 2x minus 3y equals 7, and that's never going to be the answer to the question because they're not going to give you the answer in the question, and it is parallel to some new line that I know goes through the point 1, comma 2, right? So you don't have to organize this the way I do, but even if you're not writing it down this way, it's important to mentally quantify that there are two separate lines here. So the first thing I need from this old line, I already have a point for the new line, I just need the slope. In order to find that slope, I need the slope of the old line, because parallel means same slope. So I'm going to solve this for y by subtracting the 2x to the other side, and then dividing everybody by negative 3. So at this point, I have that the slope is a positive 2/3 for this original line. Now, if you want to leave it as a negative 2 over a negative 3, that's fine. There's nothing wrong with it. It's just a little weird, but that's okay. So once I know that things are parallel, that means they have exactly the same slope, the same rise over run, the same way that staircases in your house are parallel to one another so that you don't hit your head on the staircase, or the same way that the ramp in a parking garage is parallel to the one below it so that your car doesn't drive into the ceiling. So my m, and I'm going to call it m parallel just to make it clear it's technically a different value than this one, is going to also be 2/3. So then my answer is just y minus the y value, so y minus 2, equals my m, which is 2/3, x minus the x value, which is x minus 1. Now, again, if you really wanted to solve for y, the easiest way to do so is to just add that 2 to the other side, like this. If you really want to write it in slope-intercept form, or if your teacher is making you, you can distribute that 2/3. This is going to be a 2/3 x minus 2/3, and then 2 is the same as 6/3. So a negative 2/3 plus a 6/3 is going to be a positive 4/3. Again, this is the answer I would suggest that you go with. The more math you do, the more likely it is that you do something stupid. And the higher level you get in math, the more likely it is that the mistake you make is going to be so small and so silly that you're just going to face plant, like when you realize what you did. You're going to be like, oh man, face on desk, how could I do that? So again, the less simple calculation you can do, the better. All right, cool. Let's do B. So same thing with B, I have to recognize that there are two lines. Anytime you hear the word parallel or perpendicular, you have to recognize that it is comparing two different equations. So my old equation is a 6x plus 5y equals 3, and I know that my new equation has the point negative 3 comma 1, right? So I'm going to solve this again for y just to find the slope. If you can do this in your head, if you can think in your head what's going to happen, that's not cheating, right? It's not cheating to be able to recognize that all you really need is the negative 6/5, right? If you can, in your head, recognize that your slope is going to be this negative 6/5, that's great, and you don't have to do a bunch of work, right? Now, when you get to the new slope, since this is perpendicular, you're going to flip slope, change sign, so your m perpendicular is going to be a positive 5/6, right? So now I have a point and a slope, and my job is just to write the answer in point slope. So my answer is going to be y minus the y value, so y minus 1 equals my m, which is 5/6, times the quantity x minus a negative 3, or probably write it as x plus 3. Now, if you really want to simplify this, so this is the best answer. If you want to clean this up because you stubbornly really want to solve for y, or I don't know, if you have to graph it in a calculator, you can just add 1 to the outside those parentheses. If you really, really have to clean it up, like if your teacher is stubbornly making you, which is not a thing I will generally make you do, but some people do, you could get that this is 5/6x. This will be plus a 15/6, right, which is essentially the same as a 5/2. So plus 5/2 plus 2/2 would be plus 7/2. And any of those would be fine. But again, less work is better, right? So that's the answer to E4. Now we're going to do a P4. Basically, I'm just going to erase the work I did and change the equations, right? So let's erase the work. Oh, I didn't mean to erase the word through, but that's okay. All right, so perpendicular to, parallel to. Okay, so we're going to say that this is parallel to. Let's do 3x plus 4y equals 7. And we're going to do through the point 2 comma negative 1. And over here, we'll do perpendicular to, let's do 4x minus 5y y equals 3, and we'll do through, let's do 3 comma negative 1. Cool. All right. So if you want to try these on your own, sorry, this is P4, my bad. So if you want to try P4 on your own, go ahead and pause me. I'm going to go ahead and do P4, but you can pause me to try it. All right, so again, the key here is to recognize that we have an old line that is parallel to some new line, right? So my old line is 3x plus 4y equals 7. My new line has the point 2 comma negative 1. Right? So I already have a point for my new line. All I need is a slope, which I get from finding this slope and recognizing that parallel means same slope. So again, if you can, in your head, subtract the 3x and divide by 4, it's not wrong. So if your brain is able to jump to the fact that this slope is negative 3/4, no one thinks you're cheating, right? It's not cheating to be able to do something in your head. The caveat to that is if you do it in your head and you do it wrong without work, there's not much people can do to help you. So this is what you would have done if you were writing it down. You'd subtract the 3x, you divide everybody by the 4, boom, there's your slope, right? So again, not cheating if you can jump here. Since parallel means same slope, your m parallel is negative 3/4. So then your answer is going to be y minus a negative 1, so y plus 1, equals my m, which is negative 3/4. Sorry, my brain just died for a sec. X minus a 2, right? Now, if you wanted to find the, if you want to solve, so this is the best possible answer, but if you wanted to clean this up in some way, or you wanted to solve, you could subtract the 1 over, so you get negative 3/4, the quantity x minus 2 minus a 1, that's fine. And if you really wanted to distribute, you could make this a negative 3/4 x. This would be plus a 3/2 minus a 2/2, so it would be plus a half. And that's fine too, but again, this is by far the best answer. All right, so last one, P4b. Same situation, I have an old line. It is perpendicular to a new line, right? So 4x minus 5y equals 3 is perpendicular to the line that goes through 3 comma negative 1. So if I solve this, now again, it's not cheating if your brain is able to recognize that you're subtracting the 4x and then dividing by negative 5. So if you can find that this slope is 4/5 in your head, that's not cheating. However, if you need the work, that's fine too. Remember, the important thing is to not be wrong, right? I don't assume, and I don't think most of your teachers assume, that if you don't do the work, it's because you're cheating. But we do make simple math errors, so it's safer to show the work, and then if accidentally you write something wrong, so be it. So I get that this slope is a 4/5, but because this is perpendicular, my m perpendicular should be a negative 5/4, right? So then my answer to this question is y minus a negative 1, so that'd be plus a 1, equals my m, negative 5/4, times the quantity x minus 3. Now, that's the best possible answer because it's the laziest answer. If you wanted to clean this up, you can make it y equals negative 5/4 x minus 3 minus a 1, right? And then if you really wanted to distribute, which I can't think of a good reason that you would, but if you did, this would be a positive 15/4 minus 4/4, so that would be plus an 11/4, and that's fine, right? But again, the more math we do, the more likely it is that we make a simple mistake, so I would advocate for that first answer. So that's sort of the gist of how we do parallel and perpendicular. We're going to do one more problem. We'll do an E5 that just shows you what happens if I kind of give you that point in code, right? So that's the only other way. At this moment, the only other way to make this problem harder is if I don't strictly give you a point, right? That can be more difficult. This is as hard as it gets if I hand you a point. Now, later in math, when we get to calculus, we'll talk about tangent lines and normal lines, and you'll actually have to use calculus to find slopes, and that's fine. But the hardest that this can get right now is if I give you something where you have to manipulate. So we'll do E5, which is kind of meant to be a challenge, okay? So E5, we're going to do a challenge. This is about as hard as I can make this question right now, okay? So I want the equation of a line that is perpendicular to, let's do 2x minus 3y equals, let's do 6, and we're going to say through, its x-intercept. So now, that's what makes this tricky, right? So now, when you first look at this, you're like, oh, I don't have a point for this. I have a line. So let's kind of parse this down and figure out the information that we have, right? So you see the word perpendicular, which has to mean that there are two lines. So let's talk about the old line and how it's perpendicular to some stuff I know about the new line. The problem is that right now I don't know much about the new line. right? So let's start with the old line. So I know that it's a that it's a 2x minus 3y equals 6. I know that perpendicular means flip slope, change sign. So I might as well start by finding the slope, okay? So let's go ahead and start by finding the slope of this thing. So if I were to solve this, right, so let's go ahead and find this thing's slope first, right? I'd subtract the 2x, so I'd get negative 3y equals negative 2x plus 6, and I'd divide everybody by negative 3. Now, if you were able to, in your head, do that, if you were like, cool, we're all good, I could, in my head, figure out that this is a positive 2/3, that's great, right? So, in fact, I don't even need to solve. I can just write that my slope is a positive 2/3. That's great. Now, because it says perpendicular, I know that my perpendicular slope is a negative 3/2. All right, cool. So I now have one of my two pieces of information. But what makes this problem harder than the other ones that we've done is that I say at its x-intercept, right? So that means that this line actually gives me other information it didn't give me in other points, right? Like in other problems, right? In other problems, I was talking about some random extra point. So now I need to figure out what's the x-intercept of this. So what's the x-intercept of the old line? Because what they're saying is these graphs have the same x-intercept, okay? So remember, if you think back to when we talked about graphing by intercepts, what it means to be the x-intercept, so I'm going to do this over here because I was a little out of space, what it means to be the x-intercept is that y equals 0, right? You intersect the x-axis because y is 0. So 2x minus 3 times 0 is 6, 2x is 6, x must be 3. Oh, well, there's my point, 3, 0. Now, I say, okay, cool. Now I have a point. There's my slope, there's my point, and now I can write my answer in point slope, right? So y minus the y value equals my m, which is negative 3/2, x minus the x value. And that's my answer. Now you could write your answer in a bunch of different ways. You could honestly just ignore the 0 because it's a 0. So you could write this as y is negative 3/2 times the quantity x minus 3. Or if you really wanted, you could distribute the negative 3/2 and get negative 3/2 x plus a 9/2, which is also fine. Okay? So either of those are totally fine. But again, the idea here is that you have to infer more information here, which is what makes this a challenging problem. So I'm going to give you a P5 that's similar, just to show you that this is sort of as tough as it gets. Later in math, you'll find that there are other ways that this can become a difficult question when we learn to do some calculus. But again, fundamentally, it always breaks down to the exact same question. Find the slope, find the point, write the equation in point slope. And that's really it. So let's do a P5, which will also be a challenge. Probably shouldn't have erased all of the intro because it's going to be basically the same idea. So P5, okay? So I want the equation of a line that is parallel to, let's do 3x minus 10y equals 7 through, we'll do through the x-intercept again. Oh, that won't work. They can't have the same, sorry, I take it back, not parallel. Perpendicular. If two lines are parallel and had the same x-intercept, they would be the same line. So, my bad. Okay, so perpendicular to 3x minus 10y through the, actually, let's do the y-intercept this time. Okay, cool. So, you can pause me if you want. So, we're going to do the equation of the line perpendicular to 3x minus 10y equals 7 through the y-intercept, okay? So, if you pause me, great. I'm going to go ahead and walk through it. So, here's what I know about the old line. I know the old line is 3x minus 10y equals 7, right? So, I can go, and I know that we're perpendicular. So my new line, I can find that slope by doing opposite reciprocal, right? So first thing I'm going to do is find the slope here. So again, if in your head you can subtract the 3x and divide by the negative 10, that's great. If you can jump to this slope being a 3/10, awesome. If you can't, that's okay, right? It's not a big deal. You just need to be able to get there, right? So I divide everybody by negative 10, and I'd get my 3/10, right? Since we're perpendicular, that makes my end perpendicular into a negative 10/3, right? And then we have to think about, okay, what does it mean to be the y-intercept, right? So y-intercept of the old line, right, because that's what we're saying. We're saying they have the same y-intercept, is when x equals 0, right? That's how you get a y-intercept. So 3 times 0 minus 10y equals 7, negative 10y equals 7, y equals negative 7/10, right? Or negative 0.7. Doesn't matter to me which. So that point is 0, negative 7/10, or negative 0.7 if that's what you feel better with. Once I know that, now I have a slope and I have a point. It may not be the prettiest thing you've ever seen, but it works. So my slope is negative 10/3. My point, which is slightly blocked out by the light, I think for you guys, I'm trying to block that light and I'm failing miserably. Oh well. Oh wait, there it was. There you go. So yeah, I'm so close. All right, cool. So 0, negative 7/10. So anyway, so my answer is going to end up being y minus the y value, so y plus 7/10 equals my m, which is negative 10/3, x minus 0. And that answer's totally fine. If you want, you can add the 7 or subtract the 7/10 over and get y equals negative 10/3. Honestly, I just write x instead of x minus 0 because you could distribute and you just get a 0 there, minus 7/10, and that's totally fine too. Okay? So again, this is the easier answer. That's about as hard as I can make this question at this level, is to like give you the point in some sort of a secret, sneaky way. But other than that, that's about it. So that's pretty much 1.3.